The discovery of the atom was a culmination of scientific investigations and advancements spanning several centuries. Here is a summary of the key contributions and milestones leading to our understanding of the atom. Ancient Greek philosophers, 5th century BCE. The concept of the atom was first proposed by the ancient Greek philosophers Leucippus and Democritus. They suggested that matter is composed of tiny, indivisible particles called atoms, which derive their name from the Greek word atomos, meaning uncuttable or indivisible. However, this idea was purely philosophical and lacked experimental evidence. Law of conservation of mass and chemical elements, 18th century. In the 18th century, several chemists, including Antoine Lavoisier, discovered the law of conservation of mass, which stated that matter is neither created nor destroyed in a chemical reaction. Lavoisier's experiments also demonstrated that chemical elements combine in fixed ratios to form compounds. John Dalton's atomic theory, 19th century. In 1803, John Dalton proposed his atomic theory, which provided a more scientific basis for the concept of atoms. Dalton suggested that elements are composed of tiny, indivisible particles called atoms. According to his theory, atoms of different elements have different masses and combine in simple, whole number ratios to form compounds. Dalton's atomic theory laid the foundation for modern atomic theory. Brownian motion, 19th century. In the late 19th century, the Scottish botanist Robert Brown observed the erratic movement of tiny particles suspended in a fluid. This phenomenon, known as Brownian motion, was later explained by Albert Einstein in 1905 as the result of random collisions between the suspended particles and molecules of the fluid. Brownian motion provided indirect evidence for the existence of atoms by demonstrating the presence of invisible, randomly moving particles. J.J. Thomson and the discovery of the electron, late 19th century. In the late 19th century, J.J. Thomson conducted experiments using cathode rays, which are streams of negatively charged particles produced in a vacuum tube. Through his experiments, Thomson discovered that cathode rays were composed of negatively charged particles, which he called electrons. This discovery provided evidence that atoms were not indivisible but contained smaller, subatomic particles. Ernest Rutherford and the nuclear model of the atom, early 20th century. In 1911, Ernest Rutherford, along with his colleagues Hans Geiger and Ernest Marsden, performed the famous gold foil experiment. They bombarded a thin sheet of gold foil with alpha particles and observed their scattering patterns. The results of the experiment led Rutherford to propose a new model of the atom, now known as the nuclear model. According to this model, the atom consists of a small, dense nucleus at its center, which contains positively charged particles called protons. The majority of the atom's volume is empty space, with negatively charged electrons orbiting the nucleus. Neutrons and Bohr's model, early 20th century. In 1932, James Chadwick discovered the presence of neutral particles in the atomic nucleus, which he called neutrons. This discovery completed the picture of the atom's structure, including both protons and neutrons in the nucleus, with electrons orbiting around it. Niels Bohr expanded on Rutherford's model and proposed the concept of quantized electron energy levels or shells, explaining the stability of the atom. These are some of the key milestones in the discovery and understanding of the atom. Over the years, further advancements in quantum mechanics and particle physics have provided a more detailed and complex understanding of atomic structure and behavior.